So you are a lot of people, and there are 5 p.m. So you are my hero. I try to do my best to be less boring than possible. So let's start. For people that don't know me, as he kindly said, I'm Sebastiano Galazzo from Italy. I'm the CTO of a company named Synapsia, and I deal with artificial intelligence since 25 years now, I guess. But I'm also expert in computer vision. But in 2024, AI pay much more, and so here we are talking about AI. And being specific, how to create your own large language models using open source tools. But first, let me clarify what it is the goal of this session, because that's very important in my opinion. What I will do is to share my mistakes, what I learned, and along my way. Because sometimes I realized that I spent a month, a week, 1 year trying to understand the best workflow, the best options. And so the real goal is not to teach you how that techniques works or the theory, but just to provide very, very quickly the tool for a solution. That's the goal. Okay, so you will find a lot of GitHub links, and we will talk about a little bit about theory, of course, but focused on that and much more to produce something that is business oriented and to be run in real life. Because AI can be really very expensive, you know. I guess that everybody told you. But for people that do not work with AI, I guess that they do not know how much expensive it could be. And so creating your own large language models could be a way, maybe, not always, to save money. But is it always true? Quickly, the answer is no. And there is not the perfect question, the answer that fits for everybody, because it depends. Depends on your budget, depends on your project, depends on a lot of things. So I hope to give you the tools to be able to decide. And one question, but anyway, okay, got it. But why I should start creating my own large language models, taking apart the budget? Because there is OpenAI today. It's the state of the art. It can do everything. It's perfect, and so on. Of course, if you are talking about that, in my opinion, based on my experience, is not always true. Because even $1 trillion company can fail. And could happen that for your business, for your project, it was not trained very, very well. And that's the reason why you have to start training your model. So, the easiest way to start is to fine-tuning from existing models. So in the slide before, I showed that you can use tools from Microsoft, but of course using AWS doesn't matter, whatever you want. But also Hugging Face is a very good resource, because from there you can start downloading some models. In this case, when talking about NLP, so language processing, if you want to start with something, my suggestion is Mistral version 2 nowadays. Of course, thing changes, guys. And for example, now has been released the version 3, but in my opinion, based on my experience, it's still not ready. This is the best starting point right now, okay? Someone can say, okay, but you can train ChatGPT. Okay, I did it. It's very, very expensive. And despite my experience, I was not able to make it work. I don't know why. Maybe for the dataset, I don't know, but the same dataset used with Mistral worked perfectly. So anyway, maybe I was not lucky, who knows, but happens that neither using $1 trillion product you can reach your result, because it depends on your project and your data set. So we said that you can fine-tune your large language models downloading from Hugging Face, for example. But how? Because we said that AI is expensive and training is the most expensive things, the most expensive part of dealing with AI. Just to have an idea, to train a very small model like a Phi 2 or even Phi 3 from Microsoft took 2 weeks, 96 GPU. 96. And is a very, very, very small model. Consider that we pay one GPU $3,000 per month. So that's their order. So it's impossible for common people to train your model because it's too huge. But there are several techniques that help us to do that. One of these, the most important, the one that works better than other, is this technique that is named Lora, low rank adapter. And very, very quickly, how it works. You have to imagine a large language models to simplify, of course. It's much more complex than that. But to simplify, let's imagine like a big matrix. And to train the big matrix is so expensive, as I said. Here the idea. Thanks to math properties, we can have two vectors that multiply together have the same dimension of our original matrix. So, what if I train just one vector by one other and then multiply it? I reduce the amount of trainable parameters a lot. The number says that I can train with a good GPU a model like Mistral in 2 days, compared month. That's the order. But how it works? You have to imagine this technique like you create your own matrix, private matrix, and then you add over the original matrix like an overlay. Again, to simplify, this is the idea on how it works. The quicker option is to use a vector of dimension 1, of course, and that's the rank. And you can choose also to have a wider vector that, of course, having a dimension bigger than 1, it means that it is a matrix, but you can enlarge each vector. And here we are. This slide costed to me and to my company 20,000 euros. But why? I'm going to share. Because doing a lot of tests, attempt, mistakes, you have to find the best parameter options. And sometimes it's very, very hard to find what they mean. So, this for Mistral, for example, but it works also for Llama 3, Llama 2, all these kind of models. This is the best configuration, but let's pay attention to this parameter, is the parameter R, and how it works. So, as I said, is how big is the vector. And of course, the bigger it is, the more parameter you can train. And you can think, okay, good. The more parameter I use, the better it is. but it's not always true. This is a very big mistake. First of all, yes, you can increase the ability of the model, but often lead to overfitting. Overfitting, for people that doesn't know, is when your model, when you train your model, loses its generalization capability. And based on my test, I realized that increasing that value not always lead to better result. I share this number that again costed $1,000, and this is the best configuration for Mistral in my opinion, but that's not the point. The point is that you have to understand that not always a bigger it means better. Now, another parameter, wow, it worked yesterday. Trust me, sorry, but anyway, doesn't matter. The Lora weight, the alpha, the Lora alpha, what it is a parameters that basically says how much important is the new matrix compared to the base model. So there is a ratio. So if that number is higher than 1, it means that you give much more importance to what you trained, less, of course, the opposite. Again, you can believe that if this parameter is higher, the higher it is, the better it is. It's not true. For natural language processing, I suggest you to do not exceed the ratio of 2, and for image generation, no more than a ratio of 1.5. Well, we said that you use this technique to specialize your model. Because Mistral or Llama doesn't have the knowledge that you need, because you are, for example, a legal company and you want to specialize that model to be an expert on a legal affair, okay, or medical. I don't know, I don't care. But if that works, what if I would be able to train multiple small model? Because, for example, one good thing is that the Lora model is very, very small. 600 megabytes compared to 20 gigabytes. So nothing, just the 1%, the 2% of the model. So the idea is I could train multiple Lora, expert in different domains, and to switch on the fly when there is a query from the users. So I can create an expert using my model. I'm not a fan of this technique. I'm not here to judge. I'm here to tell you can do that, and in my opinion, based on my experience, that's the best tool that I can suggest to you. So, because you can find a lot of tools on GitHub everywhere, but you spend a lot of time trying this kind of tool. Not everybody works as they said, and so on. That's a tool that I tested and it worked. Well, of course, this is not the only technique that you can use to create your model. This is just one. Lora is perfect, okay? But again, you need to spend money for the training, no less than 3 days. GPU are expensive and so on, okay? Again, another technique that is very, very cool, that gave me speechless result in a special way for image generation. So using this project for a stable diffusion is to merge existing models. It's a great idea, guys, because you can download trained model that are specialized in some domains, and you can merge together without training. So with zero cost. Of course, you can say, but it means that Lora is not good because we have this technique. No, there are different things, and you can merge together. You can combine merging models and fine-tuning with Lora, because with Lora you can fine-tune with your own data. Using the merging, you merge models already trained but by someone else. Okay, so you get what other people did. Well, this is not the session to discuss about theory and technical aspects. So, as I said, the goal is to provide you the informations, and here I can share my slides, and you can find all the resources. When you use this model, this tool that is named the Merge Kit, you can have a different way to merge your model. And depends on the situation, depends on the architecture. The easiest case is when you have two models that have the same architecture and the same initializers. I mean, for example, you can have the same architecture, but one accept an input that is 1024 tokens. It's just an example, okay? And another model has the same architecture, but different size in input. So you need to do something else. In this case, when everything matches, is the best situation, and so you have to do nothing. No training, no data, nothing. Just a few lines of Python from command line, and you can merge them. There are different techniques from basic interpolation to much more complex techniques. And again, if you are interested, you can read, and that are the best one, of course, in my opinion. Again, this is the case when you have the same architecture but different initialization. In this case, the best technique for me is the first one that makes a permutation of the weights. But anyway, it's up to you to choose the best one. But the good news, again, does everything the model. So if you are interested in understanding the math behind how they works, you can read the resources, but else, if you just need to merge two models and quickly go in production, doesn't matter, few lines or command lines, and you go. Well, the worst case, when talking about the Franken model, because they are named Franken models from Frankenstein, because you put a different part of the models and merge it together, is of course when the architecture doesn't match and also you have different initializers. But in this case, I do not suggest to use the merging. You can do that, and I'm telling to you because the tool allows to do that, but there are different solutions that works better. Works better like mixture of experts. I don't know if someone of you heard about mixture of experts, how it works. Anyway, is an architecture that works in this way. You don't have one big model, but you have several models that are named experts, of course with the same architecture, that, as the word suggests, is expert in some domain. For example, one expert could be expert in coding, another in philosophy, another in math, and so on. So, what happened is that there is a kind of router, but not so much in the beginning, but for each layer, for each node, that works like a gate. And so, based on how it was trained, it switches to the best route. What are the advantages of this kind of architecture? Why I'm going to suggest you that architecture in this case? Because you can have 5 experts with, let's say each expert has 7 billion parameters. So you can have a model that is 35 billion parameter, so is the same, running at the cost of a 7 billion parameter model. It's not always true, because sometimes happen, and that's an advantage, that if what you asked is a domain of more than one model, 2 models are activated, and then of course the cost increases. But it's not a bad news, okay? Sometimes depends. So you can think that is very, very difficult to train or to create something like that. No, because with this tool, and as you can see, it's really easy to use. What you have to do is just a configuration file. Because I don't know if you are able to see, I apologize, but maybe it could be very, very small. Anyway, of course, I share my slides. The basic idea is that you have a list of the model that you want to use as an expert, and then a list of positive prompt that you want to use as training, and to say to the framework, okay, when there is that topic, this is the model to use. So you have just to fill a configuration file with the prompts that explain, okay, when talking about coding, use that model. When talking about music, use this one. Okay. That's it. And you can create a very, very complex large language model. Well, you can do the same thing with models that are specialized in image generation, but in this case, I suggest to use the other tool that I don't know they named in this way, because large language models are Super Mario. Honestly, I don't know. Developers sometimes can be funny, but I provided to you the link, and this is the best option. I tried, and I downloaded several models from CVTI. Is another source for image generation. And really, with a few lines, just one line of code or command line, you can merge more than one model. And doesn't mean that it's so easy. So it's really easy to merge the model, but there are a few parameters that you have to understand, but works like the Lora. Okay, so there is also this lambda is the scaling factor. Instead of being named alpha, is named the scaling factor, but works in the same way. So you say how much is the difference the importance, sorry, between one model compared to another when merging. Okay. I suggest, based on my experience, do not exceed, again, not always the more is better, no more than a value of 2. Well, now let's introduce multimodal models. But first, we have to understand very, very quickly how it works, a process. The process of converting text as input for large language models. I guess that you know, but math understand just numbers. Large language models are metrics, more or less, and then the input of a large language models can be just numbers. So when you ask to ChatGPT, to Mistral, to Llama 3, hey, please summarize this text, and then all the text, everything must be converted into numbers that the models can understand. How we can do that? Using what is called tokenization. The tokenization is the process of converting, in this case, tokens, where a token is not just a word, but could be also a portion of word. And you can combine more than one token to create a word. With this technique, you can cover all the languages in the world. Okay. And for each token, you have a vector of numbers. Okay. So your text is converted as a sequence of vectors. Here, I guess that is easier to understand in this slide. So you have several objects. They're using an embedding model, let's say model. They are converted into vectors. Then, that's the real input of the large language models that is used to create the answer for your question. Here the idea, talking about multimodal models. What if I want to provide an image as input or an audio as input? It's not text. You cannot tokenize. Okay. So the idea is to find a way to convert a video, an image, an audio with the same representation of the text. So if I find a way to convert an image into the same format used for the language, so into vectors, and the same thing for the audio or whatever you want, I can use this kind of input with my large language models. This is how it works when you upload an image to ChatGPT, to Lava, and say, please describe this image. Because they use the text, is the prompt, and also the image that has been converted into vectors. And there is also a feature extractor, but you don't have to care about that. And it's used together with like it was a kind of text from a mathematical point of view as input. Well, of course, to do that from scratch, you must be Microsoft. Honestly, guys, it's not our job. Also, just training this kind of model is impossible for, I guess, unless there are billionaires in the room, but for normal people, for normal companies, simply you can't. Okay. But there are several tools, and in my opinion, this is the best one, that does the job for you. I want to share this one. Is named the multi-token. Does exactly that. Is a small framework that has been trained to take into input text, audio, images, and convert everything into vectors in order to be used by your own large language model. And once you use this library, if the model is supported, you have to do nothing, just to integrate this library and everything works, saving months and tons of money. And the input becomes something like that. I guess that you know how it works, the HTML syntax. You have messages, the role, and the content. Who use the ChatGPT already knows this kind of syntax. But in this case, you can use also, for example, images. And you pass the path, simply pass the path of your image, and everything does the magic. Having in reply this kind of output. So in this case, I asked something about the image, and here there is the answer. I can understand that seen in this way could seem things really, really too easy. But it's not. Because if you want to do that from scratch, it's something that simply you can't. Okay. And I spent a lot of time in finding and testing all these tools. So I like to share with you. Well, now we have also talking about optimization, because okay, let's say that you have created your large language models for image generation, for text, whatever you want, but performances are the pain also, not just money. Because people, users, really, I don't want to say the words, but can be painful because they want the performance. Their expectation is that the model must answer in a few seconds. In 1 second, everything. And, of course, companies like OpenAI, Microsoft, Meta has very, very expensive machines and GPUs. But if a GPU like an A100 costs 3,000 euros, just one per month, a 4 GPU costs, of course, by 4. An H100 costs 4 times more an A100. So they play a different championship. And they can run a model faster than you because they have different hardware that could cost even up to $30,000 per month. But they are rich, we are poor. So what we can do? First of all, we can use the quantization. The quantization, what it is, I guess that the speaker before me explained that this morning how quantization works. So basically, you know that the weights inside the matrix are float numbers, so 4 bytes. And these 4 bytes, of course, consume memory and affect the speed. There are several techniques that convert this weight up to an integer of 8-bit. So you can reduce the amount of RAM used by your model, and that's good, not bad. But also you reduce the complexity, because one thing is to work with integers, another thing is to work with the floating points number and with FP32, for example. Just using quantization, you can speed up your model a lot. even by 10 times. But it's not the only thing that you can do. One thing is, for example, pruning. This morning, the speaker talked about the distillation. Is a very good approach, but is not the only one, of course. And one of the most used approach is pruning, because anyway, for distillation is amazing, was great, but you need resources. Resources are money. So it depends to you. My job today is to tell, okay, that's the tool. For that case, it's up to you to say, okay, is useful for me or not. I'm not saying that pruning is better than distillation and so on. Okay, that's it's up to you. Anyway, basically, how it works. Simply, how I suggest the name. When you train a model and you do the inference, if you put an eye inside, you realize that not always the node of the model are always activated. A lot of them often are switched off. Let's say switched off. Are useless. You don't know which one, but there are, and there are a lot, but consume resources. So, there is not the perfect technique, because nobody found the perfect technique for pruning. There are several ones. But the idea is to find that lazy nodes and to cut. So the model is reduced and you gain in speed. As I told you, there are a lot of tools that you can find on the web. My suggestion, based on, again, on my experience, are that two tools. Okay, now let's talk about reg, but before, what it is, everybody knows what it is reg technique. Anyway, when you use a large language model, of course, there is a lot of knowledge inside, but it's general knowledge. If you want to manage the ticket opened by your customers that are inside the database, simply you can't, because it cannot be inside your model. Or if you want to process news from Google, okay, they are always updated. They cannot be inside your model. So what is the idea? The idea is to use several techniques that retrieve the information from the web, from your database, from everywhere, and compact that input in order to be used in real time as input for your large language models. I really simplified how reg technique works. There are a full session just for reg. Okay, so this is not the goal. Anyway, just a couple of tools that could help you if you want to retrieve, for example, images. I suggest to use this version of Lora. Lora is a model that describes your images. There are several versions. I tried all of them. Not all of them works. That's the version that today worked for me. So, if you want to save money, today that's the best option. For document processing, so for example, if you want to upload to your models PDF, docx, Office documents, I suggest to use this service just because this is the best that I know, that I use. Maybe there are other good services on Google or on AWS, I don't know, But here I am suggesting this one because that's what I tested. So, sorry, my bad. Well, when you uploaded your documents, as I said, with the same architecture of what I explained before, that everything must be converted into embeddings, we have to use a model that convert what you got into embeddings in order to be used for the search, for the retrieval. There are a lot of engines that you can use. Also, OpenAI gives you their own model, but I don't like it. Why? Simply because they are too general. Okay, I will explain. When I want to retrieve some post, for example, and I ask, please retrieve the post talking about pizza. My expectation is that the post talking about pizza has an high score compared to post talking about cars. That's my expectation. The truth, and I don't know, okay, I know why, but I cannot understand, but anyway, I can understand also that, but I do not agree, is that the difference in terms of score between the post talking about the pizza is, for example, 0.87 and the one talking about car is 0.81. So too small. Of course, the first one talks about pizza. So it works. But what can happen? Can happen that if in your workflow you decide to upload the first 3 posts talking about pizza and the first 2 talks about pizza, but the third one talks about cars, but you don't know because the score is so high that you cannot understand if he really is talking about pizza or not. You upload that content. It means that if the model is not smart enough to discard this kind of content and happen that is not able, he will not reply properly, doing mistakes. And that's a problem in real life. Because if you are playing, doing something as developer in your local machine, everything is good. But when you have to create something for customers that pay a lot of money and they want guarantee that everything works, you cannot risk, at least in my opinion. So, just in this case, also because I can, because I don't want to reinvent the wheel always, but I'm able, because I did it, to create large language models from scratch, okay? But just in this case, I created an architecture, a solution that works for my company. I want to share. I have just 1 minute, I guess, but maybe I have 2 minutes. And sorry, what I did, I used this model that is a very, very small model. Very, very small, works great, and is very, very fast. Compared to the OpenAI, OpenAI answer sometimes depends of the amount of text in 4 seconds. 3 seconds, 4 seconds. This model is able to reply the same content in 400 milliseconds, okay? But of course it's smaller because the dimension of the embeddings of OpenAI is 1538 or 84, honestly I don't remember. This is 512, so it's smaller. It means that is able to catch less details in theory, but it's not always true. Anyway, here's the problem. This is not a problem related to AI, in my opinion, but it's the life, it's the language. Okay. What I'm talking about. Let's say that you have a document that talks about cars. But it is not talking about cars. It's talking about the comparison between an Audi A6 against a BMW M5, let's say.
One question.
Okay? So, if you look the full document, that document talks about what I said. But if I reduce the window, because the models are not able to process all the document, you have to split the document in smaller paragraphs, okay, in order to be retrieved, use the technique of embeddings and so on. But if you reduce this window, here, this paragraph is talking about the battery of the car, the battery of the Audi A6. And this paragraph is talking about the performance of BMW M5. So, what is the perfect size? I cannot tell you. It's up to you. Okay.
Put my stuff here.
So, this is a reason, this is something that I cannot solve, that nobody can solve, because, again, depends on your project, on what you want to reach. But what I did to improve the retrieval of this kind in this situation.
If it's okay.
I did a mistake. It's not 520 to 512, but just so in input, this model is able to take just 128 tokens, so very small portion. Okay. So to enlarge this window, the idea is that I take, for example, in this case, four input, and basically, very quickly, so I finish, I do a concatenation of them. But you can compare vectors of the same size. And if I have this kind of size, I must have the same size for the input and for the query and for the concatenation of the paragraph merged together. So I did just a reply of the query vector, so in order to match the same size, and I did a technique that is named like a sliding window. And so what you can do is that you can compare this matrix is a method number 1 or the sliding window. If you use the sliding window, you compare the query with the first paragraph and you get the score. The query with the second paragraph and you get the score, and then you get the best score overall. In this case, instead, you just do the multiplication of the whole combination of the paragraph. It's not the same thing, because method number 2 is much more query related. So if you are looking to retrieve a paragraph based on a specific keyword, more or less. The first method, much more on the whole content. So, I'm out of time. I apologize for that few minutes. But anyway, I finished.